Hi everyone, in this video we're going to officially define what a derivative is finally. So as I commonly do, I have the first page excuse me, of this packet set aside as a preview problem. So if you would pause and try and work through this first page and see if you can kind of make some sense of what's going on here, and then I'll just zip through so that you can watch and make sure you got it right. Okay, so we have some function f, and we have a couple of x values labeled a and a plus h. So this is that whole thing I talked about where instead of emphasizing x values a and b, two different x values, this is emphasizing a starting point x value and how far away the second x value is. So we're starting with this x value a, and then we're adding h to get our second x value. We are supposed to label the points a f of a and a plus h f of a plus h. So a f of a is this one right here. And how's that yellow showing up decently? A plus h f of a plus h is right here. And for part B, we're supposed to draw a triangle whose hypotenuse is the line segment between these 2 points. So if we connect the dots, there's our line segment, and then we're supposed to make a right triangle. I'm going to draw mine down here, although I don't know if the wording implies it has to be. It could be up above as well. Okay, and then we're supposed to figure out how long each of the legs of the triangle is. So here, let me grab a smaller pen so this fits. So if we want to figure out how long this is, we would say, okay, well, we know that from the y-axis to here is a plus h, and we need to subtract off this distance, which is a, so it's a plus h minus a, which is just h, which again goes back to what I was saying before, that h is telling us how far apart our 2 points are. To figure out this distance, we would say, okay, well, we know that from here to here is f of a plus h, that's our y value. We need to subtract off this bottom distance, which is just going to be f of a. So this is f of a plus h minus f of a. Avoid the temptation to try and do anything to simplify that. Functions don't distribute, so you can't just run the f through the parentheses and get rid of the f of a's. Okay, so third part, we are supposed to calculate the slope. Let me grab a different color. Slope of this line. Okay, so that line, we've already drawn in a little slope triangle. We've got a rise right here and a run right here. So we would just take our f of a plus h minus f of a divided by the run, which is h, and that should look very familiar. There's our difference quotient showing up again. Okay, slope, let me see what I'm missing. And then the very last part of this problem asks us, so this was part C right here, asks us to find the average rate of change of the function on the interval a to a plus h. I know I'm not showing that, but let's see. So we're supposed to do the interval a plus h, and then we're supposed to calculate the average rate of change. Oops, what am I doing? AROC, there we go, on a plus h. Okay, so average rate of change, we've hopefully been getting good at making this connection, is going to be f of the second value minus f of the first value. So f of a plus h minus f of a all over the second x value minus the first x value. So it's a plus h minus a, which means our average rate of change is also equal to f of a plus h minus f of a all over h. And once again, we're just really trying to reinforce that idea that average rate of change is a slope calculation. The slope that it's calculating is the slope of a secant line. So if we choose 2 points on a curve and connect them, we get a secant line, and we can talk about its slope as a way to estimate how steep the curve is. And again, it's not always perfect. We see that here. We miss the fact that there's a little dip in there, but it averages out what happened over that interval. All right, thanks for watching.